Okay, 1.5 flow over broad-crested weir. Okay, so if broad-crested weir is installed, okay, is installed here, weir here, so uniform flow change to non-uniform flow. Okay, just remember this one. If broad-crested weir is installed, uniform flow change to non-uniform flow. Change to the water surface profile is influenced by the height of weir and the flow condition before the weir. This is upstream flow, either supercritical or subcritical. Okay, Y0 is the normal depth of flow. Y1 is the depth of flow just before weir. Okay, Y2 is depth of flow on the weir, and the Y3 is depth of flow just after weir. Okay, this is the example of the control structure using the plate weirs, using the broad-crested weirs. Okay, the V notch using the plate weirs, and the dam spillway with the weirs. Okay, all this is the control section. Okay. Okay, minimum height of weir, H minimum. Just remember this one only. Okay, H less than H minimum. So Y is 2 not the same as the YC. If H is equal to H minimum, so Y2 is equal to YC. H more than H minimum, Y2 is equal to YC. Therefore, Y2 is equal to YC and E2 is equal to E minimum if H more than H minimum. Okay, look at this table. Okay, no need to worry. You just know how to know the condition of the case 1. Okay, just case 1, case 2, and the case 3. And also the condition of flow, subcritical and supercritical. Okay, and this is case 1, case 2, case 3. So with the condition of upstream Y0, H, Y, using the H is and H minimum and E minimum, so you can know that this is submerged weir. And the case 2 here, and the case 3 control weir here. So the subcritical when Y0 is more than YC, so the figure of this case 1 is just this one, case 2 here, and the case 3 here. When supercritical, Y0 less than YC, so the condition of this case 1 is Y0 is less than Y2 less than YC. Okay, but for the case 3, so you get this one. Okay, steps in analyze flow over broad-crested weir. First, you must calculate the Y0 and YC using the subcritical and supercritical using these basic equations. Okay. Second, calculate H minimum by comparing height of weir H with H minimum and the condition of flow using this case 1, case 2, and case 3. Okay, so lastly, you must determine the Y1, Y2, and Y3. Okay, look at the case 1. Case 1, when the H is less than H minimum, so the subcritical upstream Y0 more than YC. In case 1, YC is less than Y2 and less than Y0. So this is the figure of the case 1. Okay, when it's a subcritical and when the supercritical, so the figure is just this parabolic figure. Okay, using the specific energy. Okay, so just useful equation that you use for case 1 to calculate y0 and yc. So you just use the Manning equation, all section here, and when there is a rectangular section, so you use the Manning here. So you just direct use the yc, but for the all section you use this one. Okay, use this equation. Yc is this one. Okay, for calculate H minimum, so you use the specific energy equation here, and when the rectangular, so you use this one, Q and Q here, the difference. Okay, so and E minimum, you use this equation. Okay, all this equation is will given, so no need to worry, just you must know how to use this equation in all sections or in rectangular sections. So when you use to determine the y1, y2 and y3, so you use this equation. Okay, this for the all section, this is for the rectangular section. Okay. Also same in case 2. Case 2, when H is equal to H minimum. This is subcritical and the supercritical. Okay, so the full equation that you use also all section and rectangular section. So same as the case 1. Okay, same for calculate y0 and yc and also the H minimum. But for the determine y1, y2 and y3, so you use this. Okay. Okay, this is the case 3. Okay, this is the case 3. Okay, when this case 3 is full, the case 3 here. Okay, case 3 for this equation, just remember this. Okay, useful equation is this is the same useful equation for the calculate y0 and yc, calculate H minimum is the same, but for the determine y1, y2 and y3, so you use this equation. Okay. Okay, activity 3.6, to find the depth of flow on the weir. Okay, this is all the parameter given. Step 1, determine y0 and yc. So use this, because this is rectangular channel, so you use this equation for rectangular channel. Okay, y0. So you get the y0. So you get the y0 here. Get this one. And you get the yc, 0.8605 meter. So you get less than yc. Y0 is less than yc, so you get the supercritical flow. Okay, step 2, calculate H minimum. Use this equation because this is rectangular channel. So you get E0 is 1.369 and E minimum using this equation. You get this. Okay, for step 3, determine Y2. Okay, since H is equal to 0.92 meter, is more than H minimum 0.078 meter. So this is in case 3. Okay, look at activity 3.7 to find what the minimum height of weir to control the flow in the channel, to calculate depth of flow upstream, downstream and above the weir in A, and C, calculate depth of flow upstream, downstream and above the weir if the height of weir is 0.4 meter and 0.6 meter. Okay, given y0 is 1.6, r is 0.77, s0 is 1/3000 and n is 0.01. So you just use this equation step 1, determine Y0 and YC. Y0 is 1.56 meter. So you get the YQ is 2.454 meter cube per second per meter. And you get the YC. Okay, Y0 more than YC, so you get is a subcritical flow. Okay, step 2, calculate H minimum using this equation. So you get 1.720 and the E minimum 1.275 meter. And so you get the H minimum is equal to E0 minus by E minimum, so you get 0.445 meter. Okay, for the B, step 3, determine Y1, Y2 and Y3. So in A, we know that H is equal to H minimum is the case 2. So you use Y1 is equal to Y3 is equal to Y0 0.6 meter and Y2 is equal to YC 0.8499 meter. Okay, for the C, use in this one is the case 1. So for the case 1, so you look at this one and use the equation of this one and equation of this. So you get the Y2 here. Okay, true or trial and error, Y2 is 1.032 meter and Y2 is 0.7085 meter. So you get this is a subcritical using this equation. Okay, and the C, if H is 0.6 meter is more than H minimum, so this is the case 3 backwater. Okay, for the case 3, so you use these equations and look at the case 3. Use this equation and through the trial and error, so you get the Y1 and the Y3 here is this one. Okay, so this is 1.6 flow through constricted channel. Okay, the previous slide is using the broad-crested weir, but for this slide in 1.6 flow through constricted channel. Okay, if width of a prismatic channel is reduced or enlarged at a section, uniform flow change to uniform flow, change to non-uniform flow. Change to the water surface profile is influenced by the width of constriction B2 and the flow condition before and constriction. The flow condition before the constriction. This is called the constriction. Okay, this is called constriction. Okay, this is a plan view and the bed elevation at 1, 2 and 3 are the same, is equal to E1 is equal to E2. Okay, this is the equations for specific energy. Okay, and this is the figure here. Okay, same as the broad-crested weir, but with the constriction B maximum. Okay, broad-crested weir using the H minimum, but for the constrictions using the B maximum. So just look at this equation. So you just remember this equation using the condition of this B2 more than B max, B2 is equal to B max, B2 less than B max. Okay, this is the case 1. Okay, case 1, case 2, and the case 3 for the supercritical and subcritical and supercritical. Okay, as the same, the case 1, okay, case 2, and the case 3. Okay, condition of upstream flow using the subcritical and supercritical. Okay, step 1, calculate Y0 and YC0 critical comparing with YC. So determine state of upstream flow Y0 using the Y critical at constriction. Okay, Y constriction not. Okay, subcritical and supercritical. Calculate YC2, Qmax and Bmax using this equation case 1, case 2 and case 3. And lastly, determine Y1, Y2 and Y3. Okay, so the case 1 using this one. Okay, and subcritical stream, supercritical upstream. Okay, the useful equations, because this is not rectangular, so this is using the many. Okay, and this is a rectangular. Because the constriction is using the rectangular, so use the many equation for calculate Y0 and YC0, calculate YC2, Qmax and Bmax using these equations, and Y1, Y2 and Y3. Okay, case 2 is equal B2 equal to Bmax. Okay, subcritical and supercritical. Okay, the same useful equation is this one. Just the difference for determine Y1, Y2 and Y3 is using these basic equations. Okay, the case 3, B2 less than Bmax. And the useful equation here, but the difference is at this side. Okay. Okay, look at the activity 3.8. A bridge is to be built across a 50-meter wide rectangular channel carrying flow. Okay, determine Y0 and YC. So you get Y0 is 4. You get the Q here, and YC is influenced by Q. So you get Y0 is more than Y critical not, or is a subcritical flow. Okay, calculate YC2 and B maximum using this specific energy. So you get this value with no energy loss in minimum, therefore you get this one. And get the Q max here. Okay. So this is similar to the solution and activity 3.8. So you get, but this is depth of flow upstream, downstream, and under the bridge. Okay, you just similar to solution of 3.8. Just study here. Okay, so you get the determine Y1, Y2, and Y3 in this case 1. So you get this one, and using this equation, so you get this one and this one. Okay, activity 3.10. So you just look at the solution here. First, step by step. So you must know, find the Y0 and YC0. Step 2, calculate YC and Bmax. So you get the value here. And the step 3, calculate Y1, Y2 and Y3. And lastly, you can get the Y1 and Y3 for using the try and error. Okay, this is the same. What is the constriction to be made to the channel? First step 1, you must know the step 1, step 2, and step 3. This is the same stage for the how to determine the value. You must know the step 1. Step 2, calculate the H minimum. Step 3, calculate the Y1, Y2, and Y3. And so you get minimum. And this is the figure that you must sketch if in the question asks you to sketch the figure. Okay, so this is activity 3.12. It's also the same. Sketch, and you must sketch the flow surface profile. Okay, first determine Y0 and YC0 because this is a rectangular channel. So you use this Manning equation. Okay, just put all the value here and using the try and error, so you get the y naught and yc naught. So you get the supercritical, subcritical flow. And step 2, calculate yc to NB max. So you get the yc naught here. Okay, so and use the step 3, calculate y1, y2, and y3. So you get this value. Okay. And this is lastly, you must catch using the value that you get here. Okay, so you this is the subcritical RC. Okay, so choking or flow occurs when H more than H minimum of broad-crested weir in an open channel. Okay, and B2 is less than B maximum at the constricted width in an open channel. Okay, shock conditions are undesirable in the design of culvert. Okay, design of culvert and other surface drainage features involving channel transition. Okay, that's all. Okay, look at the assignment here. Okay, thank you.